Okay, this is Unit 4, and we are going over the second breakpoint of Unit 4. So we're going to do some redox reactions, some precipitation reactions, some acid-base reactions as well. So let's get started.
Professor Lane will take you to school. AP Chem is cool.
Okay, so we are going to be doing 3 multiple-choice questions to get some practice. So this first one asks, essentially for our Bronsted-Lowry bases. So what we're really finding is we'll be looking for our base, and we're going to be solving for the conjugate base. So let's just label all 4 of our species in this reaction, and then we can easily eliminate some answers. So we have hydrochloric acid and water react to form some hydronium ions and chlorine. So let's first look at where this hydrogen goes. We're going to track this species. So this hydrogen should be here on the reverse reaction, but it's not. So this chloride lost a hydrogen. And if this species donates the hydrogen, it's going to donate. This has to be our acid, because donating a hydrogen and giving it up, that's following the Bronsted-Lowry definition. So this is our acid. And so what goes with our acid is our conjugate base, because remember, acid and bases go together. So this is our conjugate base. And if we look at the reverse reaction and go this way, we can see that this chloride ion gains a hydrogen, and that's what bases do. They accept hydrogens. And that makes sense because when we go over to here to look at our water, we see that it gains a hydrogen because it goes from H2O to H3O, which is hydronium. And so then this, if it's gaining a hydrogen, it's going to be our base. And that means this would be our conjugate acid if they asked us for it, which we don't care about the acids in this question, but we know that because if we look at the backwards reaction and we go this way, oops, bad arrow. If we go that way, we can see we lose a hydrogen because it goes from a 3 to a 2. So we know our answer is going to be our H2O and our chloride ion. So H2O and chloride is D. Okay, let's look at this question. So we have a reaction between a lithium nitrate and some H2O. So it also gives us our delta H, but we don't really need that right now. Because pure H2 is a hazardous substance, safer and more cost-effective techniques to store it as a solid for shipping purposes have been developed. One such method is the reaction represented above, which occurs at 200 degrees Celsius. So which of the following happens to H atoms in the forward reaction? Okay, so let's label our species. So this should add up to 0. All these compounds should add up to 0 because we don't see a charge on them. So we'll treat those the same. We can see that our H2O, or H2, is diatomic, and that's in its normal form. That's in its most stable form. So if an element's in its natural state, most natural state is going to be an oxidation number of 0. So let's look at our this compound to determine the oxidation numbers on lithium and nitrogen. Nitrogen changes a lot, so I usually go with the metal because lithium is going to have a oxidation number of +1 because it's in the first group of the periodic table. So we have +1 times 3, and since it has to add up to 0, we know that this one is going to be -3. So let's look over here. So we know that our nitrogen will have a -3. This will have a +1, and we need to add up to 0. So we have 1 minus 3 plus 2x equals 0 for this compound because we have 2 hydrogens. This would be -2. Add that to both sides. 2x equals 2, and so this would equal 1. So we have a +1. We have a +1 here for the hydrogen, and that's what we're looking at. We have a +1 for our hydrogen here. And then if we look here, this is a hydride, a metal hydride. And remember, in hydrides, hydrogen has a charge of -1 because this lithium will have a +1 charge. And so if we actually look at these oxidation numbers in the forward reaction, we can see it goes from a oxidation number of 0 to +1 and a -1. So this is really a disproportionation reaction, which means one species is both oxidized and reduced. Spelled it wrong. Disproportionation, I think is how you spell it. But that's what it's called. Good vocab word. Don't get a lot of those in chemistry. So we know that it was both oxidized and reduced. All right, last question. So in a titration experiment, peroxide reacts with aqueous permanganate is ion as represented by the equation above. The dark purple potassium permanganate solution is added from Bure to a colorless acidified solution of peroxide in an Erlenmeyer flask. At the end point of the titration, the solution is a pale pink color. Which element is being oxidized during the titration? What is the element change in oxidation number? So we are looking for which element is being oxidized. So let's make sure we highlight that. Pretty good. Okay, so let's assign some oxidation numbers. So we know that in a peroxide, oxygen is always going to have a -1, and this will be a +1 because this is a peroxide here. That's how we know that. That's one of our rules. Then we have 2 manganese O4 negative, which is a permanganate, but we know that it has a negative charge, so these have to equal -1. We know that our oxygen is going to have a -2 charge. So we have -2 times 4, and then plus x. And that has to add up to -1. So this will be -8. We'll add that to both sides. And so we're adding 8 to -1, which is +7. So x equals 7 for this guy. And this guy is -2. Awesome. And then our 6H positive is just going to have +1 because it has a charge on it right here. Okay, and then we will go to 2 manganese, 2 positive. So the ions always carry the charge. So this is a 2+. Plus H2O. This is a pretty easy one because it's -2. 2 times 1 is +2. They balance out to 0. And then this is 0. So again, we see from the last example that we have an elemental, so that's going to be a 0, the oxidation number there. So the only species that lost electrons, because that's what we're looking for, is oxidation. We know there our hydrogen stays the same here. We know that our manganese actually gets less positive. It goes from 7 to 2. So that really means it gained electrons. So this was a reduced species. And the only one that lost electrons is oxygen. It went from a -1 or a -2 to 0, which would mean that it got more positive. It was oxidized. Because remember, oxidation is the loss of electrons. And so we know that it was oxygen, and it changes from a -1 in the peroxide to 0 as an elemental. This was Unit 4, and I think this is breakpoint 4, so if you guys have any questions, if you guys are struggling with this, don't hesitate to let me know. Other than that, have a great day.